Alright, so this video is going to continue where we left off from the last one, but this time we're going to do examples finding extrema on a closed interval. So the last video dealt with finding critical numbers, and if we want to find the extrema, so what we know is relative extrema only occur at critical numbers. So what we're going to do is first determine if there are any relative extrema. And I do this by finding the critical numbers. And after you get the critical numbers, you find the y coordinates that correspond to these into the original function. And so this is where some confusion would be, is people not using the original function. All right, so first find any relative extrema. That deals with finding critical numbers. And after you find the critical numbers, find the corresponding y coordinates. Then you're going to plug in the endpoints. So find the y values for the endpoints of the interval. All right, so out of these, the largest is going to be the absolute max. So out of these points, the one with the highest y coordinate is going to be the absolute max. I'm going to do ABS for absolute. And then the one, same things out of these points, one with the lowest y coordinate is going to be the absolute min. All right, so this is going to be the process. So I use what we know, and what we know is that relative extrema only occur at critical numbers. So for a closed interval, I'm going to find the relative extrema, and by finding the critical numbers, and then I find the y values for the endpoints, and then out of the points, I determine which one's the absolute max and absolute min. All right, so that's going to be the thought process. So this number 25 is h of x equal to 5 minus 2x squared on the closed interval -3, 1. All right, so I first need to find relative extrema, which involves finding the critical numbers. So step 1, let's find any critical numbers. All right, first, and the critical numbers involve finding the derivative. Like in the last video, we found the derivative of the function, and in this case, h prime. of x, the derivative of 5, that's 0, and then we have minus 2 times the derivative of x squared, and the derivative of x squared is 2x. So h prime of x is equal to negative 4x. So there's no cases in which the derivative doesn't exist because this is a polynomial, and polynomials are continuous everywhere. So no cases where h prime of x doesn't exist. So I just go ahead and set the derivative equal to 0. So I set negative 4x equal to 0. And then you divide both sides by negative 4. So then that means x is going to be 0. All right, so 0 is a critical number. All right, so now I'm going to find what y coordinate goes with this critical number. So our critical number is 0. I need to plug this into the original function. The original function is h of x equal to 5 minus 2x squared. So I plug 0 in for x. That's going to be h of 0 is equal to 5 minus 2 times 0 squared. Right, so 2 times 0 is 0, so it's going to be 5. So it's going to be 5 minus 0. All right, that means we have the point 0, 5. So this is the point corresponding to the critical number. And that would be some type of relative extrema. Meaning it could either be a max or min. Don't necessarily know that. Okay, so that's the first two steps. Now I need to find the y coordinates that go along with the endpoints. And the endpoints, so our closed interval is negative 3, 1. And I plug in each of these into the function, and our function is 5 minus 2x squared. So if we plug in negative 3, that's going to be equal to 5 minus 2 times negative 3 squared. And so this is going to be equal to 5 minus 2 times 9. Okay, so 5 minus 18, which gives you negative 13. All right, that's the y coordinate that goes with the x coordinate negative 3. All right, then for the other one, for 1, all right, so it's 5 minus 2 times 1 squared, which is basically 5 minus 2, which gives you 3. All right, that's the y coordinate that goes with the x value 1. So that's 1, 3. All right, so as far as the points, I have this one, and this one. Of these, this one has the highest y coordinate. So that means this is going to be an absolute max. And the point with -13 as the y coordinate, that's going to be the absolute min. All right, and that's what we want, the absolute min and max for the function. And that's how you do this. Now, the rest of the examples, I won't write it as step 1, step 2, step 3. That's just as a demonstration of the process. And that we just find the critical numbers, find the y values that go with the critical numbers, find the y values that go with the endpoints, and then compare the points and which one has the largest or highest y values, absolute max, which one has the lowest or smallest y value is going to be absolute min. Okay, so that's that one. Now I went and skipped 23 to go ahead and show 25, because number 23, I wouldn't say it's maybe a little bit tricky. So finding the extrema, first find any critical numbers. Now if I find the derivative of this, derivative of 3 is 0, and then derivative of x is 1, so it's 0 minus 1, which equals -1. Now the derivative is a constant. And since it's a constant, this is, I mean, it's never going to be equal to 0. So this is never equal to 0, which means there's no critical numbers. Right? It's always -1 no matter what x value. So there's no critical numbers for this. So I only need to check the endpoints. Okay, so plug in -1. So f of -1 is equal to, so it's 3 minus x, so it would be 3 minus -1, which is 3 plus 1, which gives you 4. Right, so that's the point, -1 comma 4. And then the other one is plugging in 2. Gives you 1, so we have 2 comma 1. All right, we only have 2 points in this problem to deal with, so the one with the largest y coordinate is that one, so that's going to be the absolute max. And then this one has to be the absolute min. And just to visualize, so that's the answer. -1, 4 is the absolute max, 2 comma 1 is the min. What this is a line. So this is a line with y-intercept 3 because of the 3. And slope of -1. Right, because we would write it as y equals -x plus 3 in slope intercept form. And so knowing that's what it is, you can sort of visualize. So we know that's the y-intercept, and we're going, our interval is -1 to 2. So I go -1, and then you have that point, and then it's just going down, and then 2 was 1. So that's our line on the restricted in the interval. And so this is the max, absolute max, and then this is the min. All right, that's just an aside. We're looking for the calculus to support that, which is when we found the derivative and there's no critical numbers because it's a line, so there's no points in between. that are min or maxes. Okay, so that's that one. Next one's number 29. Okay, so 29 is y equals 3x to the 2/3 minus 2x on -1, 1, and finding the derivative. That'll be 3 times, and then do the power rule, 2/3 x to the 2/3 minus 1, then minus 2 times 1, because the derivative of x is 1. Now the 2/3 and the 3 can divide out, so you just have y prime is equal to 2x to the negative 1/3, 2/3 minus 1, and then minus 2. And you could write it so that the exponent is positive by bringing it to the denominator. So this will be the same thing as 2 over x to the 1/3 minus 2. Okay, so that's our derivative, and really that's the cube root. You can think of this as 2 over the cube root of x, and then minus 2. All right, so I would say note y prime doesn't exist at x being 0 because you would have to be dividing by 0, which you can't do. So y prime doesn't exist, D and E, for x is 0. Since, right, you'll have y prime equal to 2 over the cube root of 0, and then minus 2, and you can't divide by 0. So that means 0 is a critical number. Now, if you were to set it equal to 0, so if I tried setting y prime equal to 0, that's going to be 2 over the cube root of x minus 2 equal to 0. And you could add 2 to both sides. That would be 2 over the cube root of x equal to 2. And since they both have 2, you could divide out the 2. So that means 1 over the cube root of x. So 2 divided by 2 is 1, so equal to 1. And so you have a fraction, and you can take the reciprocal of both sides. Now, doing the reciprocal, so this is a little trick, is taking reciprocal of both sides so that you can flip it so that the x is in the numerator. And now if you do 1 divided by 1 over cube root of x is really what you're doing. And then you do the same thing, but you're doing 1 divided by 1. And so the left side flips it, so you have the cube root of x technically over 1, and then equals 1. All right, so cube root of x equals 1. Then you can get rid of the cube root by cubing both sides. And then cubing cube root cancels out, so you get just x equal to 1. Now keep in mind, our interval is negative 1, 1. And 1 is an endpoint. You can't have an endpoint be a critical number. Right, our interval where so we're supposed to ignore the endpoints when you're dealing with the critical numbers. So really you would handle it as parentheses negative 1 and then parentheses around 1. That would give you your range of values, which you would have your critical numbers. But in this case, since we got 1, which is an endpoint, that can't be a critical number. So that means only 0 is going to be the critical number that we apply. So only x being 0 is a critical number in our interval. Okay, so I need to find the y coordinate that goes with this critical number. So I'll write the original function. Original function was y equals 3 times x to the 2/3 minus 2x. All right, so plug in 0. That's going to be y equals 3 times 0 to the 2/3 minus 2 times 0. 0 raised to anything is 0, so this is 3 times 0, which is 0, and then minus 2 times 0 is also 0, so this equals 0. So that gives you the point 0, comma 0. So this is some form of relative extrema. All right, now that's the critical numbers, I just need to check the endpoints. All right, and our interval was negative 1 to 1 with, so the endpoints are negative 1. That means y is going to equal 3 times negative 1 to the 2/3, and then minus 2 times negative 1. Now, if you plugged in negative 1 to the 2/3 in your calculator with the parentheses, that's going to give you 1. So this would be equal to 3 times 1. And then that's going to be plus 2 since that's a negative times a negative. So that's going to give you 5. All right, negative 1 to the 2/3 is positive 1. If you put that in your calculator, you see that's what you get. So that gives me the point negative 1, comma 5. Then I plug in 1. So 1 to the 2/3 is 1, so that's 3 times 1 minus 2. So 3 minus 2, so that gives me 1. So that's the point 1, comma 1. So as far as the points, these were from the endpoints, and then the critical number had 0, comma 0. So out of my options, negative 1, comma 5 is the absolute max because it's got the highest y coordinate. And then 0, comma 0 is the absolute min because 0 is the smallest y coordinate. All right, and that's how you do that problem. And so I'll end the video here and do next video that covers the last two problems.